Okay, we're going to check out the solutions to this video. We have a live studio audience today, and perhaps some will participate. So when you guys look at number 13, we got to find our zeros first, then make a sketch of the graph. So check your papers. Should be a zero there in place of your function notation, and you should immediately begin to factor. So I would think that you look for your greatest common factor first, which looks to be x squared. Okay, so you're going to factor out your x squared, leave you with x squared plus x minus 6. Now you could at that point get your answers because the trinomial is quadratic. You could do a quadratic formula. I would think that would take too much time, so I would factor. So I'm going to go one more step. Okay, Emily, what two numbers multiply to give you negative 6, add together to give you 1? Good job. You made the video. Okay, so I'm not sure the studio audience could actually hear that answer, but Emily got that correct. Now we can definitely solve this. So the first one is x squared equals 0. Oops. And then you got x plus 3 equals 0 and x minus 2 equals 0. Now I want you to look at this carefully. This first problem, when you take a square root, you get two answers, right? So this is going to be interesting. When you take the square root of 0, you get 0. But it actually technically happens twice. So this is called a double 0 here. So we're going to mark that. Somebody had a question about that. Do I need, I guess I could just box that in. Do I need to say that's a double 0? If you take a quiz or a test on Alex, there are some questions that ask you for that information. So make sure that you realize that. And it's important when you graph. This solution will be negative 3, and that's a single 0, and this is 2. So I think we're ready to start taking a look at the graph now. So you should have all those points plotted. So we have one at negative 3. That's an x-intercept. 0. Now that one's a double 0. We'll have to remember that in a second. And at 2. So the next thing we do before we start sketching is we try to find a y-intercept if we can. So let's think back to how that works. A y-intercept has an x-coordinate of 0. So if we were to substitute zeros in for all of those x's, you realize that would just be 0. That is already a point on the graph. So that's the y-intercept as well as an x-intercept. Next thing we do is we look at end behavior to help us. So the question is, what is the degree? Tristan, what's the degree of this polynomial? You blocked out that? Highest exponent. Highest exponent. 4. That is an even number, so that's important for us. The degree is even. So that means it could look like end behavior terminating upwards in both directions or downwards. So that's important for our sketch. And then the last thing is, which one of those does it look like? That's all depending upon the lead coefficient. And the leading coefficient is a 1, and that is a positive number, right? So I'm going to put here it's positive. And if our lead coefficient is positive, things open up when they're even. So now I think we're prepared to make this sketch. We got a pretty good idea of what it looks like. So if it opens up, I think I'm going to go to the left of the leftmost point, the right of the other point, and I'm just about ready, but I do know that there's some zeros to consider. This x equals 0 is a double 0. So on that, what I'm going to want to do is put like a little parabola there. Now, I've got to wait for a second to see what that looks like because I've got to consider the other zeros. These are single zeros. I want you to make an analogy to that being like a line because x to the first power. So single's like a 1. That means that these x-intercepts are going to look like little lines that pass through the x-axis. So it might look like this. It might look like that. Now I'm going to get to the double zero in just a moment. I'm about ready. So I'm going to sketch down here. I'm going to pass through the x-axis. If I zoomed in on it like with a microscope, it would look like a line was going through there because it's a single zero. This is a double zero here at 0. Okay, I now know that it's going to look like this. Here's why. As I come down through the x-axis, I've got to turn up somewhere. I've got to turn to get back to that 0. Where this is, we've discussed, we don't really know right now. You really need calculus or a table of values, but we're just going to estimate it. So it's going to turn here, make a double zero, and it's going to turn back again somewhere, pass through the x-axis as a single zero. That's a pretty decent graph right there. These points, I don't know if those are accurate, but for our class at this level, it's okay. You go ahead and make an estimation. When you get to pre-calculus or calculus, you'll be able to figure that out. That's a derivative. Okay, so there's the first problem. You go ahead and check your work. It should look something like that. I think this turning point is actually way down here. I think it is from my memory, but anyway, that's close enough. Now, in the past, when I taught this, I have made students make tables of value to try to get more accurate. We're trying to cut down on some time to get through the material a little bit quicker, just so you know. All right, let's go to the next one. Same deal, everybody. Let's speed this up a little bit now that we've had that explanation. So let's go ahead and factor. I don't see a greatest common factor. So I'm going to factor this like a trinomial. It is x to the 4th, so you should have x squareds. Okay, Janice. What kind of numbers am I going to use here, Kaylee? Very good. You're famous. You have -9 for both because they multiply to give you positive 81, add up to give you negative 18. You can factor that more if you like, or you can go to square roots. This can be solved because both factors, by the way, are the same. Right? So we're going to have some duplicity. And they can be solved with square roots because they're quadratic. I think I'll do that. So I'm just going to write it down once. We know it appears twice. Add the 9 to the other side. Take a square root. And you're going to get plus and minus 3, right? But here's the deal. There are two factors that are the same. So those are double zeros, both of them. There's 2 3s and there's 2 negative 3s. So I'm just going to put here that they're both double zeros. That's 4 answers. That makes sense because the original degree of this is 4. It's called the fundamental theorem of algebra. We'll concentrate a little bit more on that as time goes on. I think we're ready to sketch this. That one's solved already. So let's go over here. Let's plot those points. -3 and 3. How about a y-intercept? I don't know if we're going to be able to graph this one, but if you go up here, put zeros into those x's, that would cancel out those terms. It would be 81. I can't plot that on this graph, but it would be way up there, wouldn't it? So let's just remember that. It's 81. Let's talk end behavior. The degree of this is like the other question. It's 4. That's an even number. Okay? That means it either will look like this or like that. Leading coefficient is like the last question. It's a 1. It's positive. Let me just put a plus sign there for that. Faces up. So I think we're ready to sketch this. So I'll put an arrow to the left of that point, arrow to the right, and now I know these are double zeros. Can you picture what this is going to look like now? So these intercepts will not pass through the x-axis. They're going to have to look like little parabolas. So here I go. I'm going to go down. I'm going to hit this double zero, which means I need to bounce back up and make it look like a parabola. But to get back to the x-axis, somewhere it's got to turn. Then we say the y-intercept was like 81. So I would like go way up here, way off the graph, come back down, bounce off of this again because it's a double zero. And that's a pretty decent graph. There you go. Questions? Let's take a look at the last one then. Actually, a whole bunch of people are famous because I just showed the seating chart. So, the heck? Don't worry, no one watches my channel, okay? Nothing to worry about. I have 16 subscribers, and I'm pretty sure my mom is one of them. All right, number 16. This is different. This is going to be the fifth power. So this end behavior is different. Let's see how you did with this. And this one is a little bit unfair. And I've taught you in the past or told you in the past, I can't teach you everything in a lesson. So you've got a triple zero in this problem. I don't know. I didn't grade this question. I don't know how you did with this. We need a greatest common factor. Anybody have it? What's the GCF, Tristan?
I did -2x to the x.
Good. I would take out the negative as well. It's going to make factoring easier. -2x to the third will work for us. So what are we left with? X squared minus x minus 20. That makes sense. I think we'll factor a little bit more. That's a -1 in there. Okay, Jake, what do you think? What are the two numbers that'll work? They need to multiply to give you -20, add to give you -1? Good. You're famous. -5 and 4, that will add up to give you -1. We're ready to solve it. Now, this one's a little bit different than what we've seen so far in our examples. Let me just get these set up. These solutions I'm writing now, those will be no problems. This first one. So when you solve this, if you got to this point correctly, I wonder if you did this. You got to actually divide first. And then did you know what to do here? How do you get rid of a cube? You do a cubed root. Okay, so that means x, that cube root undoes a cube. The cube root is 0. What times itself is 0? 3 times? 0. That's a triple 0. That's something new. We haven't actually had a chance to talk about it, but we will now. So that's triple. The other two solutions are single zeros. They're going to have 5 and -4. All right. We're ready to start graphing. Let's go over to our coordinate plane. Let's plot those points. -4, 0. That's the one we don't know how to graph yet. I'll show you. It's no big deal. And 5, 2, 3. How about a y-intercept? Is that something we can plot, you think? Plug zeros in for these x's. They're all going to cancel out. It's going to be 0. We already have a point at 0. So let's not worry about that. Degree of this, let's talk about our end behavior. The degree is 5, which is an odd end behavior. The most famous function we know that is an odd is a line. It's the first power. So lines tend to either look like this or this with their slope, right? Look at your lead coefficient. Check this out. It's negative. Which one of those lines is negative slope? That one is. That means our end behavior has to start over here and then end like this line that's got negative slope down there. Okay, here we go. Let's see if you got this right. Don't know if you got to this point. So -4, this intercept, is a single zero. So that means I should pass through that point just like a line would. Then I need to come back up at some point, we don't know where that is, and get to the intercept of 0, which is a triple zero. So cubic functions, that's what that is associated with. The parent function of a cubic looks like this, or like this, depending if the lead coefficient is positive or negative. It bends through the x-axis. So just in case you didn't know that, which you probably did not, I will turn back up somewhere and then kind of like curve through the x-axis like that. That's a cubic. Eventually, I've got to turn back down somewhere. Once again, I don't know where that is. I would have to plot a table of points. Let's just say it's up there. Come down through there like a line. And that's got to be pretty close to being the answer. And there you go. End of demo. All right, stop this. We'll publish that later today.